Alrighty, let's go ahead and get started. A couple of things before we get started on the exam is this. Remember, this is a departmental cumulative final exam. It is worth 30% of your grade. It is something you cannot take lightly. 30% is a whopping grade, and for my students, you know, I always have this policy that the final exam will replace, if it's higher than your lowest test grade on test 1, 2, or 3, and looking at the preliminary results on test number 4, I'm thinking about giving you guys a huge gift, which is test 1, 2, 3, or 4, whatever your lowest test grade is. If you do better on the final exam than you did on your lowest test grade, I will replace your lowest test grade. Now, I'm not dropping a test grade. I'm saying you actually have to do better on the final exam than you did on your lowest test grade, and so I'm actually making the final exam grade worth a little bit more for you guys. So if you can show me you know this stuff, and you do better on, like I said, you do better on the final exam than you did on test 1, 2, 3, or 4, well then I'm going to replace your lowest test grade with it, give you that extra boost. All right? What's that?
Just need to hang out at the end of class. I will bring their tests.
You want Desiree's class? If you are, she's going to have your test, but she will be passing it out at the end of class.
At the end of the session, I'll be back around 4, probably way before you guys are done, and I will hand them back. Okay?
Okay. And for my guys, because my grader didn't quite get them done as fast as he's supposed to, I will be giving you guys the exam back tomorrow at the exam, and I'm going to actually give it to you, and I'm going to be putting them on Moodle pretty much at the same time, but I will get it back as soon as I get them back from him and get all the great information there, and I can put it on Moodle. All right, so the other thing that I want to discuss with you guys before we get started on this exam is this. You will be taking the exam tomorrow morning. You will be there at 7:30. The exam will start promptly at 8 o'clock. It will be done at 11 o'clock. It is a 3-hour exam. Sit back and enjoy this thing. You don't have anything to do during the exam. Don't rush through it. Don't make careless errors. Take your time. You will have plenty of time to do this exam. Don't dilly-dally, but, you know, take your time, check your answers, watch the careless error type thing. So, you take the exam on Thursday. We have to send the multiple choice parts off of the exam to be graded. We typically do not get those information back until the following Monday, and sometimes it's a little bit later than that. We also have to grade the free response part, which takes us we have a big grading party. So we have to the faculty get together and have a huge fest on that. So we got to get that part. Then I got to put both parts back together again. By the time I get all this information back, honestly, I won't have any grade results, final exam results for you guys until probably around Wednesday of next week. Okay, it takes us that long to get us all back, especially with the volume of students that we have. So don't email me. Don't come by my office looking for what you did on the final exam, because personally I don't know. You will know when I have the final exam results when you guys check Moodle. As soon as I get all the information together, I will post it on Moodle. So don't email me, don't come by my office, don't call me up on the phone. The other two things, I can't discuss grades over email, I can't discuss grades on the phone. It's a violation of university and North Carolina policy. I have to actually talk to you in person before me to actually discuss any grades with you guys and stuff. So don't email me. I'm just going to check all those emails that people send to that and just pretty much delete them, because officially I can't respond to anything about grades until I get the final results back. And you have to come by my office and see me about that. And pretty much, I'm honestly, it should be around Wednesday, maybe midday Wednesday, when I have all of the final exam results back and be able to give you at least some information about your grades and stuff. But you will know when the final exam grades are back in and I got everything, because once I get them in, I'll put them on my Moodle site and you can check your grade book and see how you did on the final exam. Alrighty. Let us take a look at this exam. Remember, this exam is going to be in 3 parts. First part is no calculator multiple choice. Second part, multiple choice with a calculator. Third part, free response with the calculator. Now you have 3 hours to do this exam in. The first part, this part right here, is multiple choice, no calculator. They're going to be focusing mainly on derivatives, beating you guys up with the derivatives and stuff like that, making sure you know your rules. Now, no calculator. Now, honestly, most folks are done with part 1, no calculator part, in about 30-35 minutes. However, once you're done with part 1, you'll turn it in and you'll get your part 2 and 3. Even though parts 2 and 3 allow you to have a calculator, no one during the exam is allowed to use their calculator until 9 o'clock. At 9 o'clock, everyone must be done with part number 1 and turned it in and have part number 2 and 3. And we will make an official announcement to the entire class that, okay, everybody is done with part 1, you have to turn it in, and for the rest of you guys, you can now have your calculator. You cannot touch your calculator until 9 o'clock. Okay? So this is the way it's done, and basically in thirds. You know, the way the math department looks at it. Part 1 should be done at most an hour. Part 2 should take you about an hour, and part 3 should take you about an hour, and that's mathematically your 3 hours. Most folks are done with this exam in about 2.5 hours. There's always those loyal students that will work until the bitter end that I have to pull it out of their hands, but at 11 o'clock, pencils down type thing, and you actually have to turn it in. It is a timed event. But like I said, you got all the way up till 3 o'clock. Most students are done by 10:30, but there are some students that want to hold off on this thing until 11 o'clock. Yeah?
How similar do you think tomorrow's exam will be to this one and the previous? Can you anticipate that?
Can I anticipate how?
How close to the material and the exam will be?
All right, good question. How close is this exam going to be compared to tomorrow's exam? Personally, I don't know. Why? I'm just like you guys. The final exam is made up by a committee of people who are not teaching Calculus 1 this particular semester. So to be on this particular committee, you can't be teaching Calc 1. So you've taught Calc 1 before, just not this semester, to make it fair. So there's no faculty member teaching Calc 1 who also made up the exam. So that's kind of trying to any kind of concept like that. We know it's made up by. So I have not seen the final exam. I will see the final exam at the same time you guys do when we open the little test booklet and start looking at it. But if you look at previous history, look at not just this exam, but the semester before this and the semester before this, which I've also put on our Moodle site. I've got you 3 semesters of, including this one, of old final exams and stuff. You will look and see that they're very similar. Of course, there's difference. Word problems, I can change a word problem like nobody, but there's going to be related rate. There's going to be optimization problems. You're going to be beaten to death with derivative stuff. Find the equation of a tangent line. You know that's on there. At least 4 times it's going to be on there. So in that concept, it's very similar. But the good thing that you should be doing about this particular exam is as we do the exam and we come across a formula that you need, write it down. You write down and keep up with the different types of rules and formulas that we're using for this stuff for good memorization. All right, so this is part 1. No calculator on this part whatsoever. Let's see if we can do this thing without a calculator. Turn the page. Obviously, you will need a number 2 pencil to do this particular problem. Part out of I always use pencils on any kind of math test. I'll be using a pen just because it shows up better on this overhead thing. All right, so here we go. First question is this. Let me blow it up. You guys can see it in the back. Find an equation for the line that is tangent to the graph f of x equals x cubed minus 5x plus 8 at x equals 2. Automatically. You know this is going to be one of the first questions. Find the equation of a tangent line. To find an equation of any line, I've got to have the point-slope formula. Y minus y1 equals m times x minus x1. Point-slope form, which means I need a point and a slope. So I've got to have a point. What's my point going to be? Well, they didn't give me a point. They gave me part of a point. They gave me the x-coordinate. What do I got to do to get the y-coordinate? Plug it into the original equation. Again, no calculator, so be careful. Watch the careless errors. Plugging it in, f of 2 would be 2 cubed minus 5 times 2 plus 8. 2 cubed is 8, minus 5 times 2 is 10, plus 8. 8 and 8 is 16. Sorry, I'm off the page there. Say 8 and 8 is 16. 16 minus 10 is Last time I checked, 6. I get the point 26. Double check me on this. Watch the careless errors. Now, that's the point. The point slope formula. What is the slope of the tangent line? You've been personally programmed, for most of you, by me. When you hear the word slope of the tangent line, what are you going to use? Take derivative. The derivative of x cubed is 3x squared minus 5x is 5. But to get the slope of the tangent line, I got to plug in my x coordinate into my derivative. So f prime of 2 would be 3 times 2 squared minus 5. 2 squared is 4 times 3 is 12. 12 minus 5 is 7. Take your time. Remember, no calculator, so be careful. You'll see very quickly where students will screw this kind of stuff up at. Careless errors is the big key here. Now I'm going to plug it into my form. Point slope, y minus the y coordinate is 6 times the slope, which is 7, times x minus the x coordinate, which is 2. Cleaning this thing up, I get y minus 6 equals 7x minus 14. Add 6 to both sides. I get y equals 7x minus 14 plus 6 is minus 8. There's my answer, which happens to be answer D in my list. Okay. Now, notice a couple of things. Number one, if you're like me, I can do a problem like nobody's business. My problem is picking the guys out of a lineup. Occasionally I'll lose a sign or something or other. The trick to that is take your time. You've got 3 hours. You've got no place to go. Sit back and enjoy this exam. 2, the other thing is watch the careless errors, especially when you're plugging in numbers. Slow up, especially with no calculator. This is where places where people make mistakes. And the way we come up with these answers on multiple choice questions are we try to figure out what the common mistake is going to be and try to put one of those kind of answers on there. So take your time. Number 2. What is the derivative of the following? Well, g of x equals square root of 5x plus 3. I don't do square root. Square root is a half a power. So what rule would I use to take derivative of this guy? Chain rule. Derivative of the outside. Inside stays the same. Raised to the negative 1/2. Times derivative of the inside, which is 5. You will notice very quickly that, oh, geez, that's not one of my answers. What did they do? Clean it up. Negative exponent goes where? On the bottom. So, and a half a power is a square root, so this becomes 5, because that's a constant, stays where it's at. 2 is already on the bottom, and this negative a half is a square root on the bottom of 5x plus 3. There is my derivative, which is answer, double check, take your time, looks like answer A to me. Just like on this test that I'm showing you guys, on the final exam, you get to write right beside the questions and do all the work you need to. If you need scrap paper, we will provide it for you, but you should be able to work most of the problems right there, right beside the problem that's typed it up on. So, take the limit as x approaches 2 of 2 squared minus 7x plus 10 divided by 5x minus 10. First rule of limits, what are you going to do? Plug in a number. Let's see what we get when we plug it in. 2 squared minus 7 times 2 plus 10 over 5 times 2 minus 10. 2 squared is 4, minus 14 is negative 10, plus 10 is 0. What a surprise there. 5 times 2 is 10, minus 10 is 0. What are you going to do when you have 0 divided by 0? One of two options. You can do a chapter 1 option if you want to. 0 over 0, I can do algebra on this thing, which means it's going to factor. Or, you've already had chapter, I believe it was chapter 3, you could do what rule? L'Hopital's rule. Being this is the final exam, I'm going to go with the easiest one, emphasizing those derivatives. I'm going to apply L'Hopital's rule. But if you do algebra, you'll get the same answer. Take limit as x approaches 2. Derivative of the top, which is 2x minus 7 over derivative of the bottom, which is 5. Now plug in your number. 2 times 2 is 4 minus 7 over 5. 4 minus 7 is negative 3 over 5. Awesome. All right, one more hurdle to jump through here. That's not one of the answers they put up here. What did they put up here? decimals. And that frustrated a lot of students on this exam because I'm not allowed to use my calculator. How do I know what examples it is? Well, number one, if it's going to be a decimal or something like that, don't freak out. It's got to be easy. All right. Negative 3 over 5 is the same thing as negative 6 over 10, right? Because I multiply top and bottom by 2. Now, when I divide by 10, that's my point system because we deal with the 10 decimal place system here. So, what do we got here? This will be negative 0.6. So the answer is clearly A. Does that make sense? I don't know why they did this. I don't know. I didn't make up the exam. All right. Number 4. Which of the following is the derivative of this guy? Well, read the problem. It's x squared minus 3 divided by 5x plus 7. And if you're not one of my students, listen up, as I'll try to train you on a crash course of what I tell my students. Number 1, anytime you're doing a derivative problem, pause, hesitate, and read the problem. Reading the problem will dictate what rule should I use. What rule should I use on this one? Quotient rule. That divides by x squared minus 3 divided by 5x plus 7 quotient rule. Quotient rule is, drew the top, 2x times the bottom, 5x plus 7, minus the top, x squared minus 3, times drew the bottom, which is 5, all over the bottom, 5x plus 7 squared. Is that one of my answers? Well, be careful. Pause right when and start looking at your answers. No, they cleaned up the numerator. So, watch the careless errors, but here we go. But 2x times 5x is 10x squared. 2x times 7 is plus 14x. Distributing the negative and distributing the 5 at the same time here. I'm going to get negative 5x squared. A negative makes it positive, and 3 times 5 is, that makes it plus 15. All over 5x plus 7 squared. And even by looking at my answers, it's got to be C, D, or E here. But let's see which one it is. Combining like terms, what's 10x minus 5x? Positive 5x squared. So I was looking at these guys over here going, oh, nope, it's got to be that guy. Well, let's just double check and make sure the rest of them. My plus 14x plus 15 all over 5x plus 7 squared. And because this one's positive, clearly the only answer out there, it's got to be C. Does that make sense? Good, just good practice. Remember, this is no calculators allowed, so it's going to emphasize taking derivative of everybody. Those word problem-ish type stuff will show up more in part 2 and part 3. Which of the following is the derivative of this guy? F of x equals cosine of x squared plus 3. And I mentioned to my students, and I'm mentioning to the rest of you guys, make sure you know the derivatives of your trig functions. Sine, cosine, tangent, secant, cosecant, cotangent. All 6 of them. Don't forget the inverse trig guys as well. They are going to hit you hard on these things. And make sure you get the sign right. What's the derivative of cosine? Now, to take the cosine of x squared plus 3, I've got to use the chain rule. Derivative the outside, derivative cosine is negative sine. Inside stays the same, x squared plus 3, times derivative the inside, which is 2x. Cleaning this guy up, putting your coefficients out front, that's negative 2x sine of x squared plus 3, which is going to be, which one? Looks like B. Take your time on picking out your answers, and then immediately go circle it and bubble it in on your bubble sheet. All right, here's one that was just recently on your last test, which is still being graded. For what values of x, if any, does the function f of x equal 3x to the 4th minus 16x cubed plus 24x squared plus 10 have a local minimum? Values of x, local minimum. All right, first thing I want to do is to maximize and minimize, I'm going to take derivative. Derivative of 3x to the 4th is 12x cubed minus 16x cubed makes it 48x squared. Plus 24 times 2 is 48x. Set it equal to 0 and solve. What do I have in common on each one of these terms? Factor it out. 12x leaves me with an x squared minus, let's see here, it's 12 times 4 is 48, so that becomes 4x, plus 12 out of 48 is 4, equal to 0. So far, so good? This got factors? $12x times, how does x squared minus 4x plus 4 factor? X minus 2, x minus 2. Equal to 0. You set each factor with an x in it equal to 0, so I get x is equal to 0, and x minus 2 equals 0, which means x equals 2. X equals 2 is what we call a double root, because it's the root for the same guy. And I'm off the page there, so there you go. But, question still stands. So I found my critical numbers. The answer is 0 or 2, or maybe both of them there. 0 and 2. How do I figure out maybe one of them is a maximum, one is a minimum, or vice versa? How do I tell which one's a maximum minimum? Right. You're going to do what we call the intervals of increase and decrease to figure out max and mins here. So I'm going to draw myself a number line. And a lot of people are going, well, I don't have a calculator for this thing. You don't need a calculator. You need your brain. Let me show you how to do it without a calculator. All right. So we got 0 and we got 2. So I'm going to plug numbers into my second derivative right here. Right? Into my first derivative, excuse me. My first derivative right here. So let's see what we get. F prime of a number less than 0, I choose negative 1. Pick a number between 0 and 2. I got a brain. I'm going to use 1. And then I'm going to use 3. Okay? So here we go. Negative 1. What is negative 1 cubed? Negative 1 times 12 is negative 12. Okay? Negative 1 squared is 1 times negative 48 is negative 48. You with me so far? So this is minus 12 minus 48. And 48 times negative 1 is another negative 48. What's a negative plus a negative plus a negative? I don't care what the number is. It's just negative. So I'm just kind of analyzing what the number is going to be without actually having to go so much detail of calculating what the number is. I'm looking for patterns. Does that make sense? Next guy. Pick 1. Plugging in 1, I get 12. Plug in 1 here, I get 1, which makes it negative 48. Plug in 1 here, I get 48. What's negative 48 plus 48? 0 plus 12 makes it 12. That's easy to calculate. I don't care what the number is. It's positive. Okay, now plug in 3. Plugging in 3 on this thing is, well, got to catch a pattern here, but plugging in 3, I got 3 cubed. What exactly is 3 cubed? 27. So I'm going to analyze this from this one. That'll be 12, right, times 27. That's pretty big there. Minus 48 times 9. That'll be minus 48 times 9. Plus 48 times 3. What kind of number is this one going to be? Well, again, I don't have a calculator, but I think I can judge this thing pretty well here. I've got minus 9 48s here, and I got plus 3 48s here. How many 48s do I have? Plus or minus? Minus. There's more 9, negative 9. So that's minus 48 times 6, and I got 12 times 27. Well, what exactly is 27 over here? Break down 27. Well, it's 9 times 3 type thing here. I'm just trying to show you an easy way to get the numbers here. But it's 9 times 3, right? So 9 times 3. Let's see here. How am I quickly going to do this? I could multiply this out by hand, but and that may be the best way to show you guys what you're going to get here. Well, I can also break up 12. 12 is easily broken up to be what? 4 times 3. I was trying to get a 48 out of this thing, but it don't look like I'm going to get one. 48. It's basically 36 times 3. 36 times 9. Well, let's just do that. 36 times 9. I'm just going to show you the math here. This is 54. 9 is 27. 27 plus 5 is 32. 324. What's 48 times 6? 48 times 6 is 48, carry 4, that's 24, that's 30. 308. What is 324 minus 308? It's positive. It's like 18 or something or other, but it's positive. Again, no calculators, but you know, you can do this stuff without a calculator. And remember, you got tons of time for this section. Enjoy yourself. You got 1 hour to do this multiple choice, no calculator section. So this one, they had some numbers to crunch out, but it's easily found out that this thing is continued to be positive. So it's increasing and increasing some more. But I could have stopped there because here's the deal. What am I looking for? Well, the minimum type thing here, because let's see here. We're going down, right? And then we're coming back up. Even if it was positive or negative, I would come up and go back down. But this one comes up and goes up some more. Which one's the minimum? 0 is the minimum. I go down and come back up. So the answer is C. 0 only. Does that make sense? And I could have stopped there because once I went down and went back up again, I'm not going to get another minimum. So I could have literally stopped there. I really didn't have to do with this part at all. Does that make sense? Look for patterns on this stuff. All right. But remember, no calculator, so some numbers will be having to be crunched by hand. That's okay. They're not going to be typically too bad of numbers. The derivative of the function f of x is given by f prime of x equals 6x squared plus 3. Find a formula for f of x given that f of 1 is equal to 25. Look at this problem and tell me, think about your last test, what are they asking me to do? They're giving me the derivative and asking me to find the original function back again. They want me to enter an antiderivative of this thing. Because remember, the original function is the antiderivative or integral of the derivative dx. So the original function is going to be the integral of 6x squared plus 3 dx. Well, what's that going to be? Well, 6 is a constant, leave it alone. What's the integral? Remember, antiderivative, get your formula straight in your head, of x squared. X cubed over 3 plus the antiderivative of 3 dx is 3x. What do you got to put? Plus c for your constant of integration. So far, so good. Cleaning this up, that tells me f of x is equal to 6 divided by 3 is 2. 2x cubed plus 3x plus c. Well, that means the answer is either going to be C or E. I got a 50-50 shot now. What else do I have to do? They gave me the information right here that f of 1 is equal to 25. So now I'm going to plug in 1. This is 2 times 1 cubed plus 3 times 1 plus c equals 25. Solving for c, 1 cubed is 1 times 2 is 2. 3 times 1 is 3. 2 and 3 is 5. 5 plus c equals 25. That makes c equal to 20, which means my answer, f of x is equal to 2x cubed plus 3x plus 20. There's my answer, which is, which one? Plus 20. The answer is E. Does that make sense? Questions, complaints, comments? All right. Take a look at the next guy, number 8. A particle traveling around a circle, given the equation x squared plus y squared equals 25, where x and y are measured in inches, at the instant that the particle is at the point 3, 4, dx dt is equal to 7 inches per second. Find dy dt. What kind of problem is this? What's the name of it? Related rate. Look at these units. Inches per second. These are rate problems. You're taking the derivative with respect to time. So I've got this equation, x squared plus y squared equals 25. I'm going to take the derivative with respect to t, related rate. What is the derivative of x squared? 2x, and every time you take derivative with respect to t, you got to tack on that d variable dt. In this case, it would be dx dt. Plus, what's the derivative of y squared? 2y dy over dt. And right here is where, believe it or not, where a lot of people get lost and made a careless error. What's the derivative of 25? 0. A lot of people put 25 because they're not thinking. The derivative of it is 0. All right, plug in what we know. What are we supposed to find? We're supposed to find dy dt. I've got the point 3, 4. They're telling me this is the x-coordinate, this is the y-coordinate. So this would be 2 times the x-coordinate, which is 3. dx dt, they're telling me that's 7 times 7, plus 2 times the y-coordinate, which is 4. dy over dt equals 0. What's 2 times 3 times 7? 2 times 3 is 6, times 7 is 42. Plus 4 times 2 is 8. dy over dt equals 0. Does that make sense? Solve for dy dt. I would subtract 42 from both sides. Cancel. I get 8. dy over dt equals negative 42. Solving for dy dt, dy over dt is equal to negative 42 divided by 8. And don't forget your units. This is being measured in inches per second, just to be completely finished up with the problem here. So which one of these answers is it? Now, this, again, frustrated a lot of students because they thought, well, geez, I don't have my calculator on this part of the test. How am I supposed to do this? Use your brain. All right, 42 divided by 8. Don't hurt yourselves. Well, what's the closest number close to 42 that 8 will actually divide into? 40. Okay, so 40 divided by 8 is what? 5. And then I've got, 2 left over, and 2 out of 8 is the same thing as a quarter, otherwise known as 0.25 for you people that know decimals here. So, and it's negative, so the answer has got to be E. One of the complaints that we get as math professors about our students in college, about our freshman class especially, is their lack of knowledge of basic arithmetic mathematics. So they're making you guys run the numbers. What I'm talking about basic knowledge is you guys have been playing with calculators for a long time. And that's a problem because you're so calculator friendly, you forget some of your basic rules like what's 6 times 7 or what's 42 divided by 8 type of issues and stuff. So they're making you go back and run these classic algebra skills again. There's arithmetic skills, if you will. But it's not hard. Does that make sense? All right, take a look at number 9. Which of the following is the derivative of g of x equals x cubed times e to the 4x plus 1? Listen to it. Notice I stated the problem. When I'm stating it, I'm trying to go out of my way to tell you what rule should I use. What rule should I use on this particular problem? Product rule. X cubed times e to the 4x plus 1. So g prime of x is equal product rule. Derivative of the first, 3x squared times the second, e to the 4x plus 1, plus the first, x cubed, times derivative of the second. Remember your rules. That's another reason why you're at this review session. What's the derivative of e to a function? E to a function times the derivative of the exponents, the chain rule version of this guy. So derivative of e to the 4x plus 1 is e to the 4x plus 1 times derivative of the exponent, which is 4. Clean this guy up just to make it look like one of my answers here. This is 3x squared times e to the 4x plus 1 plus putting my front coefficient out front plus 4x cubed e to the 4x plus 1, which is answer, let's see here, 4x cubed, it's answer D. Notice what I'm doing here too. When I'm analyzing one of the answers, I take my time. It's real easy to make a careless error where I got the right answer and then I bubbled in the wrong one because I was rushing too quick. And how much points do you get for doing that? 0, because you just put in the wrong answer. Does that make sense? All right, take a look at the next guy. Oh no. Now usually I'll have to admit to you that the Newton's method problems are usually given on with a calculator section on this thing, because usually the numbers are kind of messy. So for them to put it on the no calculator section, they got to be real nice numbers to plug in. Let's take a look. Let f of x be equal to x cubed plus 8x plus 2. Use Newton's method to approximate where f of x has a 0. Start with x1 equals 1, and the first approximation calculate x2 and x3. Well, again, they got to be nice numbers for me to do this without a calculator. The big deal is you got to know the formula. What's Newton's method formula? Xn plus 1 equals xn minus who's on top? Function f of xn divided by who's on bottom? The derivative. Remember the rule. So I've got to start out with my function here. F of x is equal to x cubed plus 8x plus 2. The derivative is 3x squared plus 8. And I'm off the page there. Does that make sense? Now, to get the second iteration, that's equal to the first iteration. And what was my first iteration? They gave me that. What was it? 1 minus the functional value, plugging in 1. This would be 1 cubed plus 8 times 1 plus 2 divided by the derivative plugged in at 1, which is 3 times 1 squared plus 8. And I'm writing it this way out for your benefit, for your studying and going back over this thing. So, well, let's clean this guy up. 1 cubed is 1 plus 8 is like 9. 9 plus 2 is what? 11. So this is 1 minus 11 divided by, let's see here. What do we got here? 1 squared is 1 times 3 is 3 plus 8 is 11. Told you the numbers had to come out 9. 11 divided by 11 is the same thing as, and 1 minus 1 is 0. So that tells me right there that my x2, my second iteration, is 0. So the answer has got to be either A or B. Now I got a 50-50 shot. I can either flip a coin or do this again and actually get it right. All right, so let's do it again. 0. So the third iteration would be equal to, you plug in the second iteration, which is 0, minus the functional value at 0. Well, this is for your benefit, but you should do it in your head. 0 cubed plus 8 times 0 plus 2 divided by, plugged in 0 into the derivative, which is 3 times 0 squared plus 8. Well, that's pretty much 2 over 8, so it's 0 minus 2 over 8. What is 2 divided by 8, also known as? Negative 1/4, which is negative 0.25. So that tells me my third iteration had to be negative 0.25. So my answer is going to be, clearly it's A. Does that make sense? Questions? All right. So that one took a little bit longer on the number crunching, but now, so there should be one that's even easier. This one's a 10-second problem. Let's see if we can do it. Take the limit as x approaches 3 of 5x plus 2 over 3x minus 4. Now here's the problem, and this is why they threw it in this section. I warn my students about this all the time. Because you guys have been programmed so much on L'Hopital's rule that people just automatically tell me the answer is 5/3. And it will circle C and be done. And that's so sad, because they forgot the first rule of limits. What's the first rule of limits? And it's that easy. 5 times 3 is, I'll do it this way, 5 times 3 plus 2 over 3 times 3 minus 4. So when anybody watches this video that I'm creating here can go back and remember, plug in the number. 5 times 3 is what? 15 plus 2 is 17 divided by, let's see here, 3 times 3 is 9. Minus 4 is 5. So 17 divided by 5. All right, let's divide that out. 5 goes in 17 how many times? 3 times. And what's your remainder? 2/5. All right, but what exactly is 2/5 also known as? 2/5, same thing as 4/10, which makes it 3.4. The answer is D. And you'll be amazed how many people missed that problem. Does that make sense? What I'm also trying to do is give you guys helpful hints and also show you where people make mistakes at. That's a common mistake, is L'Hopital rule something when it's not really a L'Hopital rule problem. Okay. All right. here's one that people miss because of they really wanted to take this class 2 and 3 times. It's memorize the formula. It's that simple. The function is secant of x. What's the derivative? What's the derivative of secant of x? Secant of x, tangent of x. And if you don't know that, well, maybe next semester you'll learn it. So which answer is it? E. Yes, they're going to throw problems like that on you guys. And it's so sad how many people look at that and got that caught in the deer headlight look. Oh no, I should have remembered this one. Yeah, you're right. You should have, because it's going to be. What's the derivative of cosecant of x? Negative cosecant of x, cotangent of x. What's the derivative of cotangent of x? See, it's the quietness that worries me for the exams tomorrow. Just to let you know. All right, what's the derivative of cotangent of x? Negative cosecant squared of x. Know these rules. I know everybody's got sine and cosine pretty much down. All right, great. But what about these other ones? They're going to throw those guys at you too. What about this guy here? Evaluate the limit. Plug it in. E to the infinity. What is e to the positive infinity? Infinity. Just to remind you, it's not part of this problem, but what is e to the negative infinity? Negative exponent goes on the bottom, which makes this thing 1 over e to the infinity. 1 over infinity is 0. Things you need to have memorized. E to the positive infinity is infinity. E to the negative infinity is 0. So, here we go. If I plug in infinity on this thing, I'm going to get e to the infinity, which is infinity, times 3, which is infinity. 8 times infinity is infinity. Infinity plus infinity is a big old infinity. Divided by e to the infinity is infinity times 5 is infinity. It's an infinity over infinity problem. What am I going to use? This one is designed. Remember, 0 over 0 or infinity over infinity is L'Hopital, which means this will be equal to the limit as x approaches positive infinity of, drew the top. What's the derivative of 3 e to the x? 3 e to the x plus what's the derivative of 8x? 8 divided by, what is the derivative of 5 e to the x? 5 e to the x. Plug in infinity. E to the infinity is infinity, times 3 is infinity, plus 8 is still infinity, over e to the infinity is infinity, times 5 is infinity. Oh darn, I got infinity over infinity again. What am I going to do? L'Hopital it again. You can use L'Hopital's rule as many times as you need until you get the answer. So I'm going to L'Hopital it again. This will be equal to the limit as x approaches infinity of, derivative of e to 3x is again 3 e to the x, 3 e to the x, derivative of that's 3 e to the x, divided by, plus derivative of 8 is 0, divided by, what's derivative of 5 e to the x? 5 e to the x. But remember, with L'Hopital's rule, after you take your derivatives, clean him up before trying to figure out what the number is. What happens to my e to the x's here? They cancel. What are you left with? 3/5. But the guy who made up this exam was just real happy about decimal places. So, what's 3/5 also known as? Alright, so we want to turn it in terms of tenths, so multiply top and bottom by 2, which makes it 6 over 10, or 0.6. The answer is B. Does that make sense? Did I lose you guys anywhere? And remember, it's no calculator, but that's not an issue there. I don't need a calculator. I can convert simple decimals. All right, which of the following is the derivative of this guy? G of x equals x times sine inverse of 5x. All right, first, look at this thing. Tell me what rule I'm going to use. Product rule. X times sine inverse of 5x. Product rule. Product rule. Derivative of the first times the second plus the first time derivative of the second. Derivative of the first. Derivative of x is 1 times the second sine inverse of 5x plus the first x times the derivative of the second. What is the derivative of the sine inverse, also known as arc sine, of 5x? And what rule will I have to use? This is the chain rule version of this rule because of the 5x on the inside. Remember, the derivative of the sine inverse of x is 1 over the square root of 1 minus x squared. But the derivative of a sine inverse of a function is 1 over the square root of 1 minus the function squared times f prime of x, the derivative of the inside. So this is a function, so it's going to be 1 over the square root of 1 minus the function squared times the derivative of the inside. Derivative of 5x is 5. Now, clean them up. G prime of x is equal to the sine inverse of 5x plus x times 5 is 5x divided by the square root of 1 minus 5x quantity squared is 25x squared. Does that make sense? But honestly, I could have picked this guy out of a lineup before I even did the problem, because I knew the derivative of the sine inverse of 5x would be that 1 over the square root of 1 minus 5x quantity squared times derivative of the inside, and there is only one answer that has that kind of stuff in it. Does that make sense? So there are some that you can go through rather quickly here, but clearly the answer is going to be C. Yes? Final exam, do you have to show your work is the question. Yes and no. This is the multiple choice section. You don't have to show your work on the multiple choice because all we're grading is your bubbled in answer on the bubble sheet, on your OpScan sheet. However, on the free response part of the exam, you've got to go out of your way to show all the details of your work. Okay? So the answer to your question is yes and no. On the multiple choice, no, you don't have to show your work. On the free response, definitely show all details of your work. So you will notice we have finished the first part. No calculator section. How long did it take me to do that section? About 45 minutes. And that was with deep explanation of me going out of my way to try not to miss any steps to show you all the problems. And like I said before, most folks finish up the first part, the no calculator part, within about 35 minutes or so. Okay? But you have up to an hour. But once you're done with this thing, you go turn it in and you're going to get your part 2 and your part 3. Might as well give you all the parts together here with the calculator. However, you are not allowed to use the calculator yet. Until you're given the official word, calculators are allowed. Everybody has to turn in part 1 before any calculators are allowed. Does that make sense? So I've already got part number 2 and I'm still not allowed to use my calculator. Don't worry. Don't sit there and twiddle your thumb. I guarantee you there's probably half this multiple choice section on the part 2. Even though I'm allowed to use a calculator, I won't need it. Let's take a look. So you'll get it. Well, by the way, you will also get on this particular part a completely new bubble sheet. You will bubble that in. Last name first, first name last. You'll have to bubble in part number 2 for the second part of this thing. And you also have to put your student ID number on this side. Don't forget your student ID number, and by law, you're supposed to bring your student ID card with you. You have to have your picture ID, student ID with your 800 number on it, okay, your 49er ID card. All right, so here we go. Yeah?
Is each part weighted evenly so they're each worth 10% or?
No. Okay. 60% of the exam is multiple choice, 40% is the free response. But if you want to look at that even further, 30% for the multiple choice without a calculator, 30% for the multiple choice with a calculator, and 40% for the free response part. So if you look at 3 different parts, the free response part is actually weighted more. All right. Here we go. Remember, I still don't have a calculator yet, but don't worry, I can still do a majority of this test without it. And if I do run across a problem that does really need a calculator for it, stop right there, go on to the next problem, and once the calculator announcement is made, you can always go back and finish up the problem when you need to plug in your numbers. So don't just, I've seen too many students that will sit there during the final exam and just sit there and wait until 9 o'clock rolls around because they can't seem to do anything without that teddy bear in their hands. It's pretty sad. No, you can. You can do most of this test without your calculator. All right, here we go. Determine the values of A and B if they exist using the graph. We're doing the old limit with the graph here. One-sided limits. Take the limit as x approaches -4 from the plus side is A. Here's -4. From the plus side is down here. From the positive side of -4 is over here. What value is that? What's it going towards? So this is going to be -3. And take the limit as x approaches 2 of f of x. as I approach 2. Now, they didn't say one side or the other, so I got to approach both sides. Definition of limit. From either side, from below and from above, but you'll notice it's approaching the same number. So the limit exists, and it's approaching what number? 3. So the answer is A is equal to negative 3, and B is equal to positive 3, which is answer A. And notice I didn't need a calculator for that. Does that make sense? Number 2. Find the x and y coordinates of each point on the graph y equals x cubed plus 7, where the slope of the tangent line is 12. All right. When you get a problem that maybe you've seen, maybe you haven't seen it a long time before, break it down. Slope of the tangent lines. The words scream in my head. What am I going to do? Take a derivative. So, my derivative, which would be 3x squared, there's my function, y equals x cubed plus 7. The derivative is 3x squared. Slope of the tangent line is the derivative evaluated at a point, and that's what we're supposed to find, the x and y coordinates here. But first I'm going to find the x. So there's my derivative. Is means what in mathematics? Equals 12. Solve for x. Well, easily solve for. I'm going to divide by 3 on both sides. That gives me x squared equals 4. What kills off a square? And anytime I take a square root of a number, what do I have to take officially? Plus or minus. Don't forget that. Plus or minus. This is going to give me 2 answers. This cancels. Leaves me with x is equal to plus or minus 2. Square root of 4 is 2. This is not my answer. The question is this. Find the x and y coordinates. Now, I got 2 points here. 2 comma something or other. And negative 2 comma something or other. How do I figure out what the y coordinate is? What do I have to do? Plug it back into the original equation. What is 2 cubed? 8. Plus 7? 15. Negative 2 cubed. Negative 2 cubed is negative 8. Plus 7 is negative 1. So here are my 2 points. And now I come over here and see, it looks like the answer must be D. And on this particular problem, you'll be amazed how many folks circled C. All they forgot was the plus minus when they took a square root. And all they got was the positive version of it, and they missed the problem. Does that make sense? That's what we consider a careless error. You know the details, you just didn't fulfill it doing proper mathematics. When you take a square root, you got to do plus or minus. Any questions? All right. Number 3. The function f of x has a derivative of each value of x, and g of x equals x, natural log of f of x. Find g prime of 2, given that f of 2 equals 5, and f prime of 2 equals negative 3. All right, this was the one that frustrated a lot of students because they didn't remember their web work stuff. This is one of those things where you really don't even need a calculator on this thing. I guess we will at the end. But for the most part, it's understanding the formulas. What do they want me to do? What am I supposed to do in this problem? I am supposed to find g prime of 2. Before I can find g prime of 2, what am I going to have to do? Find g prime of x. G of x is equal to the natural log of f of x. So this is applying rules, making sure you know your rules. What is the derivative of g of x? What's the derivative of natural log of a function? All right. Derivative of natural log of x is 1 over x. But we have the chain rule version of that. What's the derivative of natural log of a function? 1 over the function times the derivative of the inside. You with me? So to find what g prime of 2 is, which is what I'm after, it's going to be 1 over f of 2 times f prime of 2. Now, this again, stolen right off of Web Workers, where this kind of problem came from. Well, I don't have the function, but they at least gave me the pieces of the puzzle. What is f of 2 equal to? F of 2 is equal to 5. So this is 1 over 5 times, what's f prime of 2 equal to? F prime of 2 is equal to negative 3. So this is equal to negative 3/5. But obviously it's the same guy making up this exam because he went decimal on it again. So what exactly is negative 3/5, also known as? Right, so this is the same thing as negative 6 over 10, which is negative 0.6, which looks like the answer is B. Does that make sense? Questions? And notice, 1, 2, 3, did I really use a calculator anywhere? No. And that's the way the exam is. Eventually you're going to run across one that you really want to use your calculator on, but we haven't found them yet. So let's take a look at number 4. Find the equation of the tangent line to the curve 12x plus y cubed equals 60y minus 52 at the point 5, 2. Well, first off, anytime they want to find an equation for the tangent line, right, tangent to the curve stuff here, I'm going to use the point slope formula. Point slope formula, y minus y1 equals m times x minus x1. Anytime I'm trying to find the equation of a tangent line. And what did they give me right there? They gave me the point. Well, half my battle is done. Being the point slope formula, and here's a point. What a gift. What do I need to have? Slope. The slope of the tangent line. What do I got to do to find the slope of the tangent line? Take derivative. What kind of derivative I'm going to have to take when I got the equation? 12x plus y cubed equals 60y minus 52. How do I take a derivative of this kind of equation? What was it called? Implicit differentiation. Because I have my x's and y's all intermixed, I'm going to jump in with both feet and take the derivative with respect to x. Which means take a derivative of x's just like normal. But every time I take a derivative of a y term, don't forget to tack on that dy dx. This is the implicit differentiation kind based on the kind of function they gave me. So, here we go. What's derivative of 12x? With respect to x is 12. Plus, what's derivative of y cubed? Being a y variable now. What is it? 3y squared, but it's a y variable, so times derivative of the inside, which is the dy dx. Equals, what is the derivative of 60y? 60, but you took a derivative of y variable, you got to tack on that dy dx. And what's the derivative of a negative 52? 0. That goes away. I'm going to solve this thing for dy dx here. So I'm going to pull all my dy dx's to one side. So it doesn't matter which side you go to. I'm going to subtract 3y squared dy dx on both sides. This will cancel here, leaving me with 12 is equal to 60 dy dx minus 3y squared dy dx. Again, I'm trying not to skip any steps, is why I'm being so elaborate. Do you have to be this elaborate on your test? No. On the free response, you do, not on the multiple choice. But now I'm going to solve for this dy dx, so I'm going to factor it out. So this will give me 12 is equal to 60 minus 3y squared dy dx. And now I'm going to solve for dy dx by dividing, and that's going to give me dy dx is equal to, I'm dividing by 60 minus 3y squared, so that shows up on the bottom over here. So that's 12 divided by 60 minus 3y squared. There's my guy, but remember, that is the derivative function. What do I want? I want the slope of a tangent line. To figure out the slope of a tangent line, I'm going to take this dy over dx and replace all my functions with 5, 2. Which means wherever I see an x, I'm going to replace it with 5. Wherever I see a y, I'm going to replace it with 2. Does that make sense? So this is equal to 12 over 60 minus 3 times 2 squared. 2 squared is 4. Times 3 is 12. 60 minus 12 is 48. So this is equal to 12 divided by 48. But 12 goes into 48 how many times? 4 times. So I get 1/4. Or for those people who love decimals over here, I think it's going to be 0.25. Does that make sense? Now, to finish off the problem, okay, at this point, I can pretty much guarantee which one of my answers is going to be. It looks like the answer is going to be C here. Does that make sense? Double check yourself. Make sure I didn't screw it up because I did also in my head. But by this time, I'm allowed to use calculator. So this will be 12 divided by parentheses 60 minus 3 times 2 squared. Close parentheses around the denominator. I get 0.25. Does that make sense? Now, just to make sure I get the right answer here, clearly I would circle C here, but point slope. Y minus y1 equals m times x minus x1. There's my point. Down here's my slope. Plugging in. Y minus 2 equals 0.25 times x minus 5. I'm going to distribute. Y minus 2 equals 0.25x minus 0.25 times negative 5. 0.25 times negative 5 is 1.25. Negative, of course. So add 2 to both sides. So I get y equals 0.25x minus a negative 1.25 plus 2 is, that becomes a plus 0.75, which really is my answer C. Does that make sense? But I could have picked that out after I found what the slope of the tangent line was, because it's the only one that has that slope. But some of them do have the same slope, so if you got to, move on, you plug it in, finish up the problem. All right, let's keep going. Next problem here is this one. Number 5, multiple choice part 2. The graph at the right is the derivative, just like on the old test I just gave you guys. The derivative of the function f of x, so it's the graph of f prime of x. They're trying to be very specific that this is f prime of x. Which of the following conclusions can be made about the function here? With a problem like this, is one of these problems that you kind of have to go through each part of the answers and make sure that it matches up. Now this is the derivative. All I can tell you about the derivative is this: that number 1, when the derivative is greater than 0, it increases. When the derivative is less than 0, it decreases. You with me? And when the derivative is equal to 0, that becomes what we call a critical number. But for when we're talking about the graph, when the graph is above the x-axis, it's considered positive. When the graph is below the x-axis, it's negative. So, f of x is increasing between negative infinity up to a, and from c to f, so that first part is right because of both those spots, it's above the x-axis, and concave down. What about concavity? Concavity deals with the second derivative. Second derivative greater than 0 is concave up. Second derivative less than 0 is concave down. But wait a minute. This is the first derivative. To get to the second derivative, I got to take the derivative of this guy. The derivative is the slope of the tangent line. So what kind of slopes are over here? Negative. So from negative infinity up to b, it's negative. From b up to e is positive, so that means it's going to have positive concavity. And from e on, it's back to negative, so I'm back to being concave down again. So from negative infinity up to b, it is concave, which one? Concave down, well that's negative, so that's correct. And from e to infinity, it's supposed to be concave down. Is it concave down there? Well, it looks like A is the answer to me. But with this kind of problem, you better check the rest of them in case there's some kind of argument here. So I'm believing A here, but let's try B. What's wrong with B? F is increasing from negative infinity up to A. Good. And from C to F. I agree with that. And it's concave down between D and F. Is it concave down here? Well, it goes concavity. It's got slope of tangent line positive and slope of tangent line negative. It's this part right here that makes this guy wrong. Does that make sense? C. F is increasing on the interval between B and E. Is F increasing here? No, it's not. Increasing means remember, this is the derivative of the function. This is the graph of the derivative. It's below the x-axis here, which means it's negative in this part, which means it's concave down here, and it's concave up in here. So this whole thing is wrong right from the get-go. Remember, this is the graph of the derivative. For the derivative to be positive, you've got to be above the x-axis. For the derivative to be negative, you've got to be below the x-axis. All right. D. F is increasing from B to E. Well, there's a problem again. B to E, it's not increasing here. It may have positive concavity here. Great. But remember, this is a derivative, so it's below the x-axis, means it's negative, or decreasing here. From C over, it's increasing. So this is wrong. And same idea with E. It's wrong because between B and E, they still talk about it increasing, but it's clearly going to be decreasing in this little section over here. So this is wrong. So the real answer is what we thought before. The answer is A. Again, with a problem like this, look at the wording of this guy. This is one of those problems that you want to take your time and go through each of the answers. Question? Yes, sir.
Can you explain that first part of A, the negative infinity is less than x is supposed to have?
Okay, for this first part up here, this is the derivative. For the derivative to increase, you've got to have the first derivative's got to be positive. When you're looking at the graph of the first derivative, for the first derivative to be positive, you've got to be above the x-axis. To be negative, you've got to be below the x-axis. So here's your line in the sand right here, because here is your x-axis. You with me? So between negative infinity up to A, you are above the x-axis. That means you're positive there. Positive derivative means you're increasing. So between negative infinity to negative A, I should be increasing. That's what it's telling me I am doing. And from C, here it has 0, you hit 0, over here to F, I am above the x-axis. Above the x-axis means I'm positive. This is the derivative. Positive derivative means I'm increasing. So all that matches up. Now the concavity is the derivative of the first derivative, right? Dealing with second derivative. So look at the derivative or the slope of the tangent lines of this particular graph. You will notice between negative infinity up to B, my slope of my tangent lines are negative because I'm going down. That's the second derivative, which tells me that I'm going negative. Second derivative means I'm concave down. Right? And that's what it says. I'm concave down there. And between E to infinity, my slope is still down, but this is the derivative of the derivative, making him the second derivative, which means being down means second derivative is negative, means I'm concave down there too. Number 5. A cube is measured to have edges of length 10 with a possible error of 0.03 centimeters. Use differentials. Again, this is when we study these old exams. Been a while since you seen the word differentials and stuff. Use differentials to estimate the maximum error in calculating the volume. All right. I want to remind you of your differentials. Okay? What does delta stand for? Change. Your change in your function is equal to f of your fixed point plus delta x minus f of your fixed point. This is how much you're changing in y coordinates. This can sometimes be a very painful thing to calculate. This is the actual change in y or change in your function. The differential formula is, we use a little d. df, or differential of f, is equal to the derivative at the good point times delta x. This is my differential form. This is the differential. Okay? What are we playing with? A cube. What's a cube? Well, a cube is a block that all the sides are the same. We'd call this guy x by x by x. We're talking about the maximum error in volume. What is the volume of a cube? Well, it's length times width times height, but being a pure cube, all the length, width, and height are the same. Hence, what do I get? The volume is going to be x cubed. You with me so far? All right. So, now they want me the maximum possible error. That possible error, that right there is my change in x. How much I'm allowed to have my change in x. It's 0.03. Visually plus or minus. So far so good? Now, my differential for volume is going to be the derivative. What is the derivative of my volume equation here? What's the derivative of x cubed? 3x squared times, and instead of delta x, I should have put a dx there, doing differentials, I'm sorry. dx and delta x are approximately the same thing here, but this should be a dx here. And so this will be times dx. But remember what I just said, delta x is the same thing as dx in your differential form. So plugging these numbers in, and by the way, what was x equal to? Length of what? 10. So x is equal to 10. They're giving me all the pieces of the puzzle. All I got to do is plug them in. But you had to know the differential form. So this is equal to 3 times 10 squared times, plus or minus officially, 0.03. Plugging each part into my equation. So this is going to give me plus or minus. 10 squared is like 100, times 3 is 300, times 0.03 is what? 9. So the answer is 9. This is change in volume. So in volume, this length is measured in centimeters. So this will be centimeters cubed. So the answer is going to be D. Does that make sense? Did I lose you anywhere? Do you remember your differential form? It's the derivative of your function times dx. And remember, dx and delta x, the change in x, approximately the same thing. So you're going to substitute that number in. All right, number 7. Which of the following limits represents the derivative of f of x equals the sine of 2x plus 1? Now, my students, I've been warning you guys about this for about 2 weeks now. You got to go back to your chapter 1, chapter 2 stuff and remember your formula. This is one of those ways they can ask you this question. The limits derivative, the basic definition of derivative. Do you guys remember the definition of derivative? Good, because it's on your test, I guarantee. They always ask 1 or 2 questions on this thing. What's your definition of derivative? It's the limit as h goes to 0 of f of x plus h minus f of x divided by h. This one is an easy problem with this because they didn't ask me to calculate it using the definition of derivative. That's what you see on the free response part of the test. This one, they want to know which limit actually gives me the derivative. So all I got to do here is, here's my function right here. Let's plug in our stuff. This will be the limit as h goes to 0 of, if f of x is equal to sine of 2x plus 1, what would f of x plus h be? Sine of 2 times x plus h plus 1, because the rule is wherever there's an x, we're just going to plug in x plus h. Minus f of x, just recopy the function, the sine of 2x plus 1 all over h. Clean them up because it looks like they distributed to me. So this would be equal to the limit as h goes to 0 of the sine of 2x plus 2h plus 1 minus the sine of 2x plus 1 all over h. This is defining my derivative, which looks like it is going to be, which answer? Take your time. It looks like you. Nope, sorry. Does that make sense? Questions, complaints, comments? All right. Next guy. Oh, you know these guys are going to be on the test. Here it is. Find the maximum area of a rectangle whose base is on the x-axis and one side on the y-axis and one vertex on the line y equals negative 5x plus 90 as illustrated. Awesome picture here. All right, so I'm going to get a little bit more on the picture here, but this is the x-axis. Here's my y-axis. This is the line y equals negative 5x plus 90, and we're making a box. Remember my 6 steps to glory on how to maximize or minimize anything. Step number 1, draw a picture. Well, they did that for me. Label it. I'm trying to figure out what? I'm trying to figure out the coordinates of this maximum area of the rectangle. I'm trying to maximize the area of the rectangle. So focusing on the rectangle, this is movement in the x direction, so this is going to be x. This is movement in the y direction, this is y. So this is the actual point xy, which is on this line, y equals negative 5x plus 90. What do we want to do? Step 1, read problem, draw picture. Step 2, come up with the objective equation. The objective is to, in your life, being a Calculus 1 student, take a derivative of somebody, set him equal to 0, and solve. This is your life. Who do you want to take derivative of? What do we want to do? Maximize area. I need an area equation. That's the objective equation. What's the area of a box? We want to maximize this area here. Area of a rectangle is length times width. Based upon my letters, that's x times y. I want to take derivative of this guy, set him equal to 0, and solve. I got the standard problem. What's my problem? Too many letters. So now I got to come up with the constraint equation. They gave me some additional information about this problem. What is my constraint equation? Well, they actually gave it to me. Y equals negative 5x plus 90. Step number 4 is to take said constraint equation and solve for one of the variables, which they did, and plug it into the objective equation. So this is going to give me area equals x times negative 5x plus 90. Let's bring him down here and clean him up. Area is equal to negative 5x squared plus 90x. How do you maximize or minimize anything? What am I going to do? Take derivative, set him equal to 0, and solve. So area prime would be equal to negative 10x plus 90 equals 0. Solving, negative 10x is equal to negative 90. Divided by negative 10 on both sides. This gives me x is equal to 9. Step number 6. The most important step on winning points on the old exam here is go back and answer the question. What was the question? They didn't ask me what the x-coordinate was. They asked me what? Find the maximum area. Got to find the area. Well, I know what x is. The area is this equation here. Area is equal to negative 5x squared plus 90x. So what am I going to do? Plug in 9 into x's. That'll be negative 5 times 9 squared plus 90 times 9. And by this time, I clearly have a calculator here. So now, here we go. Negative 5 times 9 squared plus 90 times 9. I got 405 units square, if I wanted to be accurate about this, because this is the area. Units square. But the answer is 405, which is answer B again. Does that make sense? Questions? All right. Number 9. The second derivative of the function f of x is f double prime of x equals x cubed minus 9x. Find the x-coordinate of each point of inflection. This is a definition thing, and this is a nice, easy 10-second problem here. Why? Because they gave me the second derivative. How do I find points of inflection, inflection points? What do I got to do? All I do is take that second derivative and set that sucker equal to 0. So my second derivative was given to me to be x cubed minus 9x equals 0. You with me so far? So I will factor out an x. That leaves me with x squared minus 9 equals 0. That's a difference of squares, so I can factor it out some more. That'll be x plus 3 times x minus 3 equal to 0. I set each factor equal to 0. And I get x equals 0, x equals negative 3, and x equals positive 3. Does that make sense? But be careful. It actually worked in this problem, but I can't guarantee in this always working. The definition of a point of inflection is where you change concavity. Does that make sense? You have to change concavity from concave up to concave down, or vice versa, concave down to concave up. That's what we call a point of inflection. To truly test that these are points of inflection, you should do your number line and plug things into your second derivative. So the numbers are in order, negative 3, 0, and 3. Pick a point to test. Remember, we got calculators at this point, so it's going to be a lot easier to test now. F prime of double prime of negative 4 I'm going to plug in. Pick a number between negative 3 and 0. I choose negative 1 because it'll be easier to plug in. F double prime of negative 1. F double prime of positive 1. And F double prime of positive 4. All right, so and here's my calculator at the ready, plugging in -4 into my derivative. And they gave me the derivative, so it's -4 quantity cubed minus 9 times -4. I got -28. Don't care what the number is, it's negative. So it's concave down in that interval. Now I'm going to try -1. The old second entry, changing all the -4s to -1s. I get positive 8. Don't care what the number is, it's positive, which tells me it's concave up in that interval. Plug in 1, so get rid of all the negatives. Plugged into my second derivative. I get -8, which means it's back to concave down in that interval. And pick like 4, plug into my derivative 4, and I get 28. It's back to being positive. The deal is this. I'm going from concave down to concave up to concave down to concave up. It's changing concavity in each one of these things. That tells me that all 3 are points of inflection. There are 3 points of inflection, -3, 0, and +3. And this is my answer. If, setting you guys up for the exam here, if I did this and got negative, positive, more positive, and then negative, in that case there would have been only 2 points of inflection. Because going from positive and more positive, that doesn't make it a point of inflection because you're not changing concavity. Does that make sense? Did I lose you guys anywhere? All right. Yeah.
How, so the second derivative had 3 values for x after you factor and solve for it.
Right.
How could that not, how could one of those not be an inflection point across the next axis?
The true definition of an inflection point is where you change concavity. So if I did this test value and it was negative, then it was positive, then you test them again, it was more positive, and then it's back to negative. The only places that it actually changed concavity, going from negative to positive or from positive back to negative again, would have been at -3 and +3. Those would have been the only points of inflection. Okay? Inflection points, by definition, change concavity. You're going from concave down to concave up. Okay? So, I mean, I can make you draw some weird shaped graphs and stuff, but I could be concave up, stop here, and then be concave up some more. It stops for a moment and stops being concave 0 type of thing, so it kind of flattens out a little bit, then it concaves more. That, by definition, is not going to be an inflection point. The definition of inflection point is you actually have to change concavity from negative to positive, positive to negative. Same idea with critical numbers. How do I have max-min numbers? I have to go up and then come back down again on the increase-decrease. I go up and come back down, that makes maximums. I go down and come back up, that makes minimums. If I go down, stop for a second, and go down some more, that's no longer going to be a critical number. It's not going to be a max-min number anymore. Does that make sense? I'm talking about max-min numbers. It won't be a max-min number anymore. Does that make sense? It's where you change concavity. But, and this one was easy because it changed it all up. The graph of the function f of x is given below. Find the x-coordinate of each of the local maximum and each of the local minimum. All right? So, this one is about as easy as we can make it, I guess. I guess they felt bad with all those decimals or something or other. So here we go. Fine. This is the function of the actual function. This is y equals f of x. Who are my max-min points? Well, he's the dude on top. That makes him a maximum. He's the dude on bottom. That makes him a minimum. He's on top, so that's a maximum. He's on bottom, that's a minimum. So according to my calculations, the maximums are going to be at what point here? A and C. The minimums are going to be at B and D. Okay, so which one of those answers is it? A and C is the maximum. A and C are maximums. B and D are minimums. So, looks like the answer, just to double check. I think I know which one it is. Which one is it? Yeah, pretty much. All right. Don't feel bad. You hope and pray that you guys get a question like this on the test too. Out of all these other ones, this is at least, here's some free points for you. Yeah?
If I
That's true.
F close to 0 and
True. When you have a function that is defined over a closed region, a bound between like two endpoints, you have to, your max mins could be at the critical numbers in the middle or the endpoints. You always compare them to endpoints. But on this particular problem, did they give me any closed interval that this thing's defined over? It's defined over everything, and they even grew out the picture for me, so you just keep on going. So this is it. They never mentioned anything about an interval. Only between 0 and infinity. Well, then in that case, C would be the only maximum, and B would be the, and actually a 0 would be a minimum there too. If they put it over an interval, I have to check endpoints. But that's not what they gave me in this problem. Yeah. Uh-huh. Yeah. Okay, so this problem, B would be an absolute maximum by definition on this particular problem. But remember, absolutes are also locals, but locals not necessarily absolutes. But all they're talking about is local max and mins here. So being a min point, it's going to be local here. But you're saying, what happens if I have bounds? Let's say right there. This one, now defining my region between these 2 points here, I'll call this point E over here because it doesn't have a name. All right? Where's the absolute maximum going to be at? E, that I just made up. Where's the absolute minimum going to be at? It'll be at B. Way over a closed region, then you start discussing the concept of absolute maxes and absolute mins. Number 11. Find the absolute maximum and absolute minimum. Oh, I'm glad you brought it up. On the function f of x equals 2x cubed minus 150x squared plus 50,000 on the interval between negative 20 and 20. Okay? How do I find critical numbers first? What am I going to do? I'm going to take derivative, set it equals 0, and solve. What's my derivative here? 6x squared minus 300x. What's the derivative of 50,000? 0. Equal to 0. I can clearly factor out an x, just to make it easy on myself. That leaves me with 6x minus 300, equals 0. Now I set each factor, x equals 0, and 6x minus 300 equal to 0. This gives me 6x equals 300, divided by 6 on both sides. That gives me x equals 300 divided by 6. Or for those people who want decimals, which it looks like maybe what we want here, 300 divided by 6 is 50. So far, so good. Now, here is the most important spot, and this is where a lot of people miss this problem at. To be a absolute max and minimum, you have to find your critical numbers, take derivative, set it equal to 0, and solve. But you also have to make sure that your number, your critical number, is within your region that you're looking for. What is the region that I'm looking for? Negative 20 to 20. Look at my numbers. Is x equals 0 between negative 20 and 20? Yes, he is. Is x equal 50 between negative 20 and 20? No, he is not. It is a problem number you cannot use. It's not within your interval. So I only have one critical number because it's not inside my interval. Does that make sense? Not in negative 20 to 20. So, here we go. I only got one critical number, which is 0. This will be my CN. Then I will compare it to my, these are my CPs, critical points. Now I'm going to compare it to my EPs, my endpoints. What are my endpoints? Negative 20 and positive 20. Now, I'm going to go back and plug in these numbers into my original function. Well, I'll do the first one. You guys do the other ones. I plug in 0, I get 50,000. That wasn't too bad. Plug in negative 20. All right, time for calculator again. This will be 2 times negative 20 cubed minus 150 times negative 20 squared plus 50,000. I get negative 26,000. Now plugging in 20, I'll do that one. Second entry, change all the negatives to positive. It's kind of nice. So delete the negatives here. I get 6,000. How do I tell which one is the absolute maximum, which one is the absolute minimum with this stuff? You look at the y-coordinates. Which one is the biggest y-coordinate? So this one is your absolute maximum value. Which one is the smallest y-coordinate? Negative 26 value, so that would be the absolute minimum. So which one is that guy? The absolute maximum is 50,000, so it's either one of the last two guys, and the absolute minimum is 26,000, which is, answer is D. Number 12. Find the first graph. The first graph on the left below is the graph of y equals f of x. Which graphs, labeled A, B, C, D, and E, best represent the graph of y equals negative f of x minus 1? This is Chapter 1 Algebra Review. There is no calculus involved in this whatsoever. All right, so first thing I want you to do is separate this guy. This is your picture. We want to figure out what is y equals negative f of x minus 1. And just for space purposes, I'm going to write them up here and describe them to you. Y equals negative f of x minus 1. Order of operation, work inside the parentheses. Help me out here. What does a minus 1 do to my graph? Which way is it going to go? To the right 1 unit. Inside parentheses, you kind of use the opposite. So I say a minus 1, so that's going to go to the right 1 unit. So I'm going to shift this thing right 1, right? And then what is a negative outside my function going to do for me? Reflect it across the x-axis. Reflects across x-axis. In English, that means it flips it upside down. So I'm going to flip it upside. I'm going to shift it to the right 1 unit and flip it upside down. So if I take this graph and shift him right 1 unit and flip him upside down, he's going to be in this first quadrant someplace. So which one takes this guy, shifts it right 1 unit, and flips it upside down? Looks like D to me. Does that make sense? College Algebra, Chapter 1 review stuff. They felt bad, I guess, and had to put that on there. All right, so here we go, number 13. Read the directions. The derivative of h of x is given by h prime of x equals negative 7 times x minus 2 squared times x plus 3 times x minus 5. Find the x coordinates. The only x, since you don't know h of x is, for each of the local maximum and each of the minimum of the function, if any. All right. So, what did they give you in this problem? Derivative. How do you find maxes and minimums? What are you going to do? Take derivative and do what with them? Set them equal to 0 and solve. So here's my derivative. H prime of x, which is equal to negative 7 times x minus 2 squared times x plus 3 times x minus 5. I'm going to set him equal to 0 and solve. When I set him equal to 0 and solve, what I do is I take each factor, since it's already been factored for me, mighty decent of them, set each factor equal to 0 that has an x in it and solve for that guy. That gives me x is equal to 2, x is equal to negative 3, and x is equal to 5. These are my critical numbers. As you guys are frantically copying, let me tell you where a lot of people screwed this problem up at. And I saw them when they were taking this exam. It was so sad. You know what they did? They didn't read the problem. They were taking the derivative of this thing. They were using the triple product rule. You know, drew the first times the other two guys, plus the middle one times the other two guys, plus the last guy times, the derivative of the last guy times the other two guys, and creating some awful function trying to figure out where the critical numbers are. And they kind of missed the point. What did they give you? You don't have to take a derivative. If they gave you the derivative, all you had to do was set it equal to 0 and solve. But we got to figure out who's max, who's min, which means I've got to do a number line. Finding these intervals of increase and decrease tell me who's max, who's min. Because if I increase, I go up, and then I go back down again, that means I'm on top, maximum. If I go down, decreasing, and I go back up again, that means it's a minimum. But don't forget to put these things in order. That was the other mistake I saw. So sad, you get all this work and you can't seem to figure out who's in order. Who's the smallest one up here? negative 3. Who's the next guy? 2, and then 5. We're going to do test values. F prime, pick a number between negative infinity and negative 3. I choose negative 4. I have a brain, so a number between negative 3 and 2, I pick 0, because clearly. Pick a number between 2 and 5, I choose 3. And bigger than 5, I choose 6. You guys can see it. There we go. Now, what I'm going to do is a test value. I'm going to plug it into this thing. Now, you can plug it in by hand, but I'm going to show you a trick on how to do it on the calculator rather quickly here. So, what I would do if I was going to do this problem and test these values is this. I would type in just in my derivative into my function here. That would be negative 7 times x minus 2 squared, less chance for careless error is what I'm trying to show you here, times x plus 3 times x minus 5. And I'm just going to do a zoom 6, and I don't care what the graph looks like. Doesn't interest me whatsoever. A bunch of lines everywhere. That's okay. Here's what I'm going to do. I'm going to do values on this thing, so all I want to do is plug in these numbers into the calculator. If you ever notice second calculate number 1, it says value. That's what I'm going to do is plug it in. So number 1 value, what's the first number I'm plugging in? This is my derivative here. I'm going to plug in negative 4. And I get, crappy big numbers here, but that's all right. We're in the calculator section. Negative 2, 2, 6, 8. Don't care what the number is. What's the sign of it? Negative. Means I'm decreasing in that interval. Now I'm going to pick 0 and plug it in. I get 420. That's positive. So it increases there. Plug in 3. I get 84. So I'm back to increasing some more there, which means 2 is not a maximum point at all. And plug in 6. And I get negative 1008. I'm back to negative again. That's an 8 in case you can't read my handwriting. Here you go. Does that make sense? All right. So what does this mean? Now this is your first derivative. This is called the first derivative test. I am decreasing and then I am increasing. What does that make? Negative 3. X equals negative 3 is a minimum. All right. I go up some more. What does that make 2? Nothing that I care about. So keep going. I'm positive, I'm going up, and then I go back down again. What does that make 5? So x equals negative 3 is the minimum. X equals 5 is the maximum. Let's see if we can figure out what this one is. Maximum came first, so it's 5 at maximum. So which one is 5? Looks like B here. Local minimum at negative 3. The answer is B. And if you notice, what we've done now is this. We've gone through the entire Part 2 multiple choice section here. How many questions were on this section? 13 questions. How many were on section number 1? 14 or 15, I can't remember now. 14 questions. So they deviate each semester. So yes, sir. Hold on, back question on number 11 here. Oh, number 11, yes. 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 All right. Difference in the question here. This problem, they asked me to figure out absolute maximum minimum. So I have a function over a closed region. Anytime you've got a function over a closed region, you first have to find your critical numbers. So you do take that derivative. Here's the common thread. You take derivative, set it equal to 0, and you solve. But you make sure those numbers, that your critical numbers, are inside your interval. Then, for being on a closed interval to figure out absolute maximum minimums, and that's the difference. This is an absolute maximum question. You plot your critical numbers into the original function versus plot your endpoints into the original function and pick out who's got the biggest y coordinate, who's got the smallest y coordinate as absolute max, absolute min. On problem 13 over here, this question was find the x coordinates of the local maximum minimums. Because I can't tell, because they only gave me the first derivative. They never gave me the original function if they're going to be local or global. Okay? Absolute max and mins. So all they want is to know who's going to be max, who's going to be min. And there's no closed interval on this thing either. Where did they say only look in between negative 100 to 100 or something like that? Nothing was that was it. This is a local max min question. And they gave me the derivative. So a major thing, but it's in the difference in the wording and what was given.
It wouldn't give us a problem. We have to take the integral of A and have the derivative from that.
No, that's not for the absolute max mins or a local max min. It's not like that. They will give you a derivative and ask you what the original function is, but that's the and understanding the last concept we did, which is antiderivatives, integrals, getting you guys set up for Calc 2. Well, how long did that one take me? About 45 minutes, and that was me being long-winded on it too. So, trying to explain every little part. So now we're on to the free response. So I took about 45 minutes on the first one, and being long-winded, and I took 45 minutes on the second one, and being long-winded. So how long have I taken this exam thus far? Hour and a half. How much longer do I have? I got another hour and a half to go, and all I got to do is now part 3. Okay? So I got tons of time to do this stuff. You have no life. You're college students. Sit back and enjoy this. Don't rush through this exam. Don't like you got something to do at 10 o'clock or something or other, because you're not going to make it. Sit back and take the time on the exam. Watch the careless errors. All right. Now, the difference in between the last two sections and this section. This is the free response. You want to go out of your way to show your work. Because we do grade on partial credit. Because if you can get majority of the problem done, even though you may have messed up a careless error someplace on some number, you can still get some major points out of the thing. Another thing is this. For the majority of you people, you are my students. And we all have reputation around here, and I like to consider my reputation at this university real good. And the reason why is because I have the bright students. You represent me, therefore you will be one of the bright students. You will not embarrass me. You will do well on this exam and make me look good, because that's what life is all about, making me look good. Remember that. Now, other thing is this. We have a habit in calculus that when we're getting ready to grade these final exam things here, when we have our little group committee thing, that a lot of students, the ones that typically aren't doing real well in this class, like to make comments on the old final exam. Now, granted that some of these comments are actually quite funny, and I enjoy reading them as long as they're not my students' comments, because it actually embarrasses whoever the professor of that student truly is. So if they're sitting there commenting on how crappy a problem this happens to be on the final exam, honestly, we don't want to hear about it. It's just that you think it's crappy because you can't do it. Everybody else seems to, so you're just showing your ignorance. Don't show your ignorance. You know something about each problem this final exam. Never leave anything blank. Write something down. If you know something about every problem, you covered Calculus 1, never leave anything blank. Even if you can't seem to figure out what the answer they're looking for is, write down what you do know about the problem, so maybe you can pick up a point here, a point there, a point everywhere, and get some major partial credit on the thing by writing down something intelligent instead of, this was a crappy exam. We don't need to hear that. Okay? Let the people who want to make those comments come from other people's classes, because they're obviously failing anyway. All right, so here we go. Don't leave anything blank. You know something about every problem. Let's take a look at the first one. Answer the question below based upon the information about the function f. You must justify your answers, a.k.a. show your work. Okay, here we go. The function f is continuous and differentiable for all values of x. 2. F of x is greater than 0 for x less than 0. F of x is less than 0 for x is 0 less than x, which means x is greater than 0. F prime of x is greater than 0 for between -6 to 2, -2, and 5x greater than 5, reading it going this way. 4. F prime of x is less than 0 for x less than -6 and between -2 to 5. F double prime of x is greater than 0 for x is less than -4 and between 3 and 7. F double prime of x is less than 0 for -4 to 3 and for x is greater than 7. And then we're supposed to answer a bunch of questions. All right. Before you do this problem, they love to get this kind of problem to you. What you should do is this is kind of detective work. Take their information, and see if you can't figure out what the function looks like. Because once you get a picture in your mind of what the function looks like, it's going to be real easy to answer these questions. Does that make sense? The quick trick to this kind of a problem is, they want information about a function. Let's give them a function. Let's give them the picture of it. Because from the picture, it's easy to answer questions. So I'm going to put this all together to see if we can't figure out what's going on here. All right. It tells me this. F of x is greater than 0 for x is less than 0. What does that tell me? Less than 0. Here's 0. The function is going to be up here someplace. I don't know where it is, but I know it's positive, right? The function is greater than 0. That means it's above the x-axis. This is my x-axis. And the function is less than 0, which means the function is below the x-axis for x is greater than 0. 0 less than x. X greater than 0. So over here, the function is going to be down here. Does that make sense? For anything x greater than 0, the function is going to be negative, which means below the x-axis. Now, let's move on to part 3 here. It is continuous and differentiable, which means, I forgot part 1. It's continuous. I don't have to worry about any gaps or anything. And it's differentiable. I don't have to worry about any cusp, any sharp turns. It's going to be nice and smooth. Does that make sense? Number 3 here. F prime. What does F prime measure? Increasing and decreasing. Going up versus going down. F prime of x is greater than 0. It means I'm going up between -6 and -2. So I got to put some hash marks up here. So let's do that. -1, -2, -3, -4, -5, -6, -7. And let's go over here. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you go beyond the numbers they give you, and that's what I'm doing over here. So, f prime of x is greater than 0, which means I'm increasing between -6 and -2. Between -6 and -2, right in here, I have to increase. So I'm making it a little darker. I'm going to be increasing here. And for x is bigger than 5. Here's 5. I've got to be increasing. Remember, the graph is down here, so I've got to increase as I go from that point over. Does that make sense? Again, I'm putting it together. Overall, I'm going to put it all together. You're going to see a nice, elaborate picture, and it's going to be easy to answer these questions. Keep going. F prime of x is less than 0. It means it's negative, which means I'm decreasing. For x is less than -6. Less than -6. That's over here. I've got to decrease. So I'm going to be coming in like this. Okay? And between -2, here's -2, and +5, I've got to, like I said, decrease. So here was at 2 right here. Kind of there. I got to decrease, so I've got to come and connect those things. So I know I'm going to go up, down, up. Now I'm going to put the bend into this thing. You see what I'm doing? I'm being very elaborate with this graph and trying to put all the pieces of the puzzle together. So it takes a little bit of time, but trust me, once you get this picture, watch me go through these answers very quickly and get to the next problem. All right, so we keep going. Now we got to the second derivative. That deals with concavity. Second derivative greater than 0. That means I'm concave up. Where am I concave up? X is less than -4. Here's -4 right here. So concave up. So now I'm going to put the bend into this thing and make it a little darker even yet. So I'm concave up in that interval. You with me? And between 3, here's 3, and 7. Here's 3, and here's 7 that I made up. I'm concave up here. Connect my dots. Does that make sense? Okay, just keeps on going that way. Now, where about this one? F double prime of x is less than 0. What does less than 0 mean? Concave down between -4 and 3. -4 and 3, I got to be concave down. Does that make sense? At those particular points. Concave down. And greater than 7, I got to be which way? Concave down. So I'm going to be concave down going like this. That's concave down. There is my picture. What is this telling me? Can you interpret from this picture max and mins and things like that? Well, I got this point right here. What point is that guy right there? Maximum. Where's it at? according to my picture here. It's supposed to be at 2. What about this point right here? Minimum, it's at -6. What about this point right here? It's a minimum at 5. Okay? This point right here at 3, I'm changing from concave down to concave up. Here's point here at 7. And this point over here, and I believe it was at -4. Right there. What are these points? This point, and this point. Inflection points. That's where I'm changing my concavity. Does that make sense? Now, let's go answer the questions. On your mark, get set, make an A. On which intervals is this function increasing? Increasing means I'm going up. Where am I going up at? -6 to -2, -6 to -2. I'm using interval notation. We would have taken it either way. Where else am I increasing at? From 5 to infinity, right? Union 5 to infinity. There's my answer. What is the x-coordinate of the local maximums of any? Do I have any local maximums? Yeah, where's the big point at? Right there. Remember, these guys continue going up. These are arrows here, so it keeps on going up that way. So what do we got here? Where's the local maximum at? What value is that? So x equals -2. On which intervals is the function concave down? Where am I concave down at? Concave down is in here. What was those numbers between concave down? That's the second derivative negative, so that would be what? -4 to +3 union 7 to infinity. It's concave down over here too. That's concave down in here. Does that make sense? And last but not least, what were my x-coordinates of my inflection points, if any? What inflection points did I have? X is equal to -4, x was equal to 3, and x is equal to 7. Does that make sense? Yes, question. Uh-huh. No, because if it went down, it would have to go, and then you would have to be decreasing some more. I never said a decrease. So I'm going to go up like this, and maybe it may level off a little bit, but it's still going to be slightly increasing. So yeah, it's going to go up. It doesn't say it's going to go back down again. You have to read what it says. Remember, by increasing, it says that for increasing, when x's are greater than 5, it will continue to increase. I may be up here someplace. I'm not sure. But all I know is it's concave down over there. Pay attention to this up here. All right. Well, there's 10 points. All right, let's keep going. All right, remember this one. You know where they stole this one from. That's right, web work. So they love to go back to problems on web work and see if you guys can't figure out how to do some of those. All right, here's the classic chart problem. Again, trying to work those derivative rules, but without actually giving the functions. Here's my chart right here. Find f prime, b prime of 3, given b of x is equal to f of x divided by g of x. Well, here's the deal. If I'm going to find b prime of x, what rule do I have to use to take derivative of f of x divided by g of x? Quotient rule. Drew the top times the bottom minus the top times drew the bottom all over the bottom squared. Right? Plug it in. Again, this is showing my work. This is what we wanted to see. Now, b prime of 3. X is equal to 3 here. Plugging it in, that's f prime of 3 times g of 3 minus f of 3 times g prime of 3 over g of 3 squared. What is f prime of 3? Well, x is 3 right here. F prime is 6. G of 3, here's g of 3 is 2. F of 3, here's f of 3 is 4. G prime of 3. Here's G prime, here's 3, that's 8. Over G of 3, here's G of 3, which is 2, squared. And I'm off the page there, sorry. Does that make sense so far? Which gives me equal to, let's see if we can crunch this number out. 6 times 2 is 12. Minus 4 times 8 is 32. Divided by 2 squared is 4. I got, what'd you guys get? Negative 5. And I come over here and circle it. B prime of 3 is equal to negative 5. Does that make sense? Questions? Now, let's talk about partial credit, because I've saw a lot of people when I was grading this particular problem on the exam is this. They would write this down. You know what they screwed up? Picking numbers off the chart. So sad. And then they got the wrong number in here somehow and end up getting a wrong answer. So let's say this was a 3-point problem. By writing this and this down and you trying to plug in the numbers to it, they could find where your mistake was at, and they only took off a point on that and gave you 2 points for it. So at least that's 2 points you would have had. That you would, remember, out of 3 points, that's 2 points you would have had. Showing your work is very, very important. Questions? All right, take a look at B. H of x is equal to f of g of x. H of x being equal to f of g of x. How do I take derivative of h prime of x? What rule am I going to use? Chain rule. F is on the outside, g of x is on the inside. So f is on the outside, chain rule. You take derivative of the outside, the inside stays the same, times derivative of the inside. This is the chain rule version written in letters. Derivative of the outside, inside stays the same, times derivative of the inside. This is what we wanted to see. Now I want to calculate h prime of 1, which would be equal to f of g of 1 times g prime of 1. F of, when working functions, you always work inside the parentheses. What's g of 1 equal to? G is, there's g of x of 1 is equal to 3, so that's f of 3 times g prime of 1. F of 3, here's f of 3 is 4. G prime of 1, here's 1. Hold on. Excuse me, there's a prime there. Excuse me, you're right. I'm trying to rush to it. G of 3 is, sorry, G of 1. Get it right. G of 1 is 3. So I did that right. But now I want f prime of that. F prime of 3, excuse me. F prime of 3 is actually 6. That's what happens when you rush. Remember, I've got no place to go. I should take my time. G prime of 1. What is G prime of 1 going to be equal to? Here's 1. G prime of 1 is negative 5. So what is my answer to my problem? Negative 30. And go over here and always circle your answer so we can find it. H prime of 1 should be equal to negative 30. But remember, this is the work they wanted us to show. Have I lost you guys anywhere? Be careful of this guy. G of 1 is equal to 3, but I want f prime of 3. So there's my f prime of 3, which is equal to 6. So that's where my 6 came from. Does that make sense? Take a look at the next guy. Find k of 4 for k of x is equal to f of x quantity cubed. We want to find k prime of x first. What rule would I have to use to take derivative of f of x raised to the third power? Chain rule. Derivative of the outside, inside stays the same, quantity squared times derivative of the inside. But now we want to find k prime of 4, which will be 3 times 4 squared times f prime. Sorry, lost my f there. Sorry about that. F of 4 times f prime of 4. That's f of 4. What's f of 4 equal to? 3 times, what is f of 4? F of 4 is equal to, there's h, put it down here, x is 4, f of 4 is what? 2. So it'll be 3 times 2 squared times f prime of 4. Here's 4. F prime of 4 is equal to negative 7. Take your time. Don't make careless errors. Now, cleaning this up, let's see here. 3 squared is 4. Excuse me, 2 squared. 2 squared is 4 times 3 is 12. Times negative 7 is negative 84. And there's my answer. K prime of 4 is equal to a negative 84. Does that make sense? Questions, complaints, comments? So it's real easy. Just be careful with the chart, because that's where a lot of people mess it up at, is they were going through it so quickly and they were grabbing wrong numbers off the chart or whatever. Be careful. Questions? All right, take a look at the next guy. Question number 3. The height of a projectile at time t is given by the equation h of t equals 200t minus t cubed. Calculate the average velocity over the time interval between 5 and 10. You know what the sad part about this problem was? How many students left it blank? You know why they left it blank? Couldn't remember the formula for the average velocity. Average velocity is equal to f of b minus f of a over b minus a. It's also known as the old slope formula. Where my h is, in this case, it will be h. So this will be h of 10 minus h of 5 over 10 minus 5. Does that make sense? Because they gave me the time interval between 5 and 10. Now all I got to do here is plug in 10 in this equation. So this is 200, and I'm just going to do this on the calculator to show you. 200 times 10 minus 10 cubed. I get 1,000 minus plugging in 5 into this thing. So call it back down and change all my 10s to 5s. I get 875 divided by 10 minus 5 is 5. And this would be 1,000 minus 875, which is 125 divided by 5 is 25. And I'm off the page there. Yes? Yes, it is. You are correct. But that's with instantaneous velocity. That's not what they asked in this problem. What did they ask? Average velocity. No, that would actually give you, and divide by 10 minus 5, that actually would give you the average acceleration. The average velocity is the change in distance over change in time. H is the distance formula. So I'm changing my distance here from 5 seconds to 10 seconds. So this is the difference in the height over the difference in the time. Change in distance over change in time. That's the definition of average velocity. If they ask for the word instantaneous velocity, that's when you use the derivative. Okay? Now, did they give me any kind of units for this thing? No, they didn't. They should have, but they did not. So imagine this thing being in like feet and time being in seconds, then what would the units on this thing be? Feet per second, because it is a velocity. And if they give you units, don't forget to put units down on the answer. With this one, they didn't. So all you have to do is tell me that the average velocity is equal to 25. Now, compare that, since you brought it up, and they're setting you up for calculus here, compare that to Part B. What are they asking you in Part B? Use some calculus, I don't know why, but use some calculus to find the instantaneous velocity at time equals 5. So when they hear the word instantaneous velocity, what are you going to use? Derivative. So my distance formula is h of t is equal to 200t minus t cubed. So h prime of t, which is your instantaneous velocity equation, which would be equal to 200 minus 3t squared. Now that's the formula for it, but what do they want? They want this velocity at 5 seconds. So that's h prime of 5, which is 200 minus 3 times 5 squared. 200 minus 3 times 5 squared, Well, let's see here. 5 squared is 25 times 3 is 75. 200 minus 75 is 125. And if this thing had units, like feet and seconds or meters and seconds or kilometers and hours or miles and hours, what would your units be? Miles per hour, feet per second, meters per second, something like that. Number 4. Oh, what a surprise. Didn't you guys see this problem on your test? Good. All right. So, find the area of, a rectangular area of 60,000 square feet is to be fenced off in the diagram below. A large rectangle divided into 2 smaller rectangles. What are the dimensions of the area that uses the least amount of fencing? And give exact answers and then approximate to the nearest foot. All right. First thing, what are we supposed to do? We're supposed to find the dimensions that uses the least amount of fencing. All right. So what we want to do is minimize the amount of fencing here. So here we go. First thing, draw a picture. Well, they drew it for me nice. And label it. I'm going to call this side X and this side Y. Okay? Read problem, draw a picture, label it. Now, the other thing is this. We've got to come up with the objective equation because we're going to minimize fencing. So the equation, the objective is to figure out the fencing equation. So I can take its derivative, set it equal to 0, and solve. How much fencing am I using on this particular problem? Well, I'm putting fence here and here and here, which makes it 3x plus here and here for y's, 2y's. I want to take rid of this guy, set him equal to 0, and solve. That is my life. My problem is too many letters. So what am I going to do? Well, I got to come up with the constraint equation. What is my constraint equation? What was given in this problem? The area is equal to 60,000 square feet. So they actually give me units on this one. Remember that. They're giving me units. So look at my answers when I'm done. Now, what is the formula for area based upon this big rectangle box thing here? Area, which is equal to x times y, must be equal to 60,000. Step number 3 is actually take your constraint equation and solve for one of the variables so you can substitute back. What variable do I want to solve for? I'm going to solve for y. Dividing by x on both sides gives me y is equal to 60,000 over x. Now I'm going to take this guy and plug him into the y of my objective equation so I can get that objective equation in terms of one variable. F, fencing, would be equal to 3x plus 2 times 60,000 over x. Substitution. I'm going to slide it up so we can actually do some calculus now. Clean this guy up. F is equal to 3x plus 2 times 60,000 is 120,000. X to the negative 1. I brought him off the bottom because I'm going to take derivative of this guy. So far, so good? Now, to maximize or minimize anything, what am I going to do? Take derivative, set him equal to 0, and solve. Derivative of 3x is 3, plus the derivative of 120,000 x to the negative 1 is negative 120,000 x to the negative 2. Set him equal to 0 and solve. Clean him up. This is 3 minus 120,000 over x squared. Negative exponents go back on the bottom. Equal to 0. Which means I'm going to move this to the other side, solving for x. So 3 is equal to 120,000 over x squared. Now, when I moved them to the other side, I added 120,000 x squared to both sides. Okay, so this would have canceled. That was my point. Now what am I going to do? I don't like fractions, so what am I going to do? Multiply both sides by x squared, so I get 3x squared is equal to 120,000. Then I'm going to divide by 3 on both sides. Gives me x squared is equal to 120,000 divided by 3 is 40,000, of course. And now, what do I got to do to figure out what x is? Square root. Now listen to my words. Officially, if I'm solving for x, I'm going to do a plus or minus. However, this is a construction problem, and we're building fences. It doesn't make any sense to make them negative. That would be imploding upon itself. So there is a sense of logic in terms of your answers that you dictate. So I'm not going to do plus or minus on this one. It's construction. So what is the square root of 40,000? 200. But we're not done. What is the last thing I always do to any kind of max-min problem? Go back and answer the question. They had two major questions here. Here we go. What are the dimensions of the area that uses the least amount of fencing? And then, quote, give the exact answer and then approximate it to the nearest foot. Which really bothered us graders because the answer was 200. But I think this is what they wanted you to do. All right? So the dimensions would be what? What is the dimensions of my rectangle here? It is x by y. You with me? I know what x is. What's x equal to? 200. What's y equal to? Remember, y was equal to, I go back up to my constraint equation, which is way up here. It's 60,000 divided by x. So this is 60,000 divided by 200, right? Plugging it into my constraint equation. And 60,000 divided by 200 is 300. You with me? So it's 300. Now, in terms of all this elaborate rounding it to the nearest foot type thing here, this is what they were trying to not be so in your face about how they wanted the answers, but don't forget the units is what they should have said. But they just try to make you remember the units by telling these elaborate words. What was x? It's a distance. And what is it measured in? Feet. And y was a distance, and it was measured in feet. So the answer to the question is the dimension should be 200 feet by 300 feet. Does that make sense? Questions? Now, this problem, this was one of the problems that, again, from a grading perspective, we had a real problem with because, let me explain to you from a professor, you guys taking the exam and trying to maximize your score. I saw a lot of students, well, not a lot, but quite a few students. Yeah, I would say a lot of students, but remember, there were about, I don't know, 1,000, 1,200 students taking calculus this semester this thing came out. Actually, a little more than that. This is Calc 1. Almost 2,000 students taking this exam. And some people tried not to, they got the answer, but they didn't use calculus on it. What they did was they basically tried to figure out, by plugging in numbers, and because the numbers were actually pretty nice, 200 by 300, they could actually get the answer without actually coming up with calculus, without taking the derivative, setting it equal 0 and stuff like that. So we had to make a decision how many points you should be awarded for something like that. It's a 10-point problem. We decided nothing. So make this as a calculus class. What are you supposed to be using? Remember that. All right, so number 5. A boat. You've seen this problem because I put this problem on one of my little note things here. Okay, a boat is pulled into a dock by a rope attached to the bow of a boat. All right? The rope passes through a pulley at the dock that is 4 feet above the bow of the boat. If the rope is pulled at a rate of 3 feet per second, how fast is the boat approaching the dock when it is 10 feet away? Find the exact answer and then approximate it to the nearest 0.01 feet. Go for the decimal per second type thing here. All right, so here we go. What kind of problem is this guy? Related rate. It is your related rate problem. You know that by, pay attention to units. What do they tell me here? There's 3 feet per second. And there's two major word problems we've covered all semester long. 2 major word problems. They are related rate word problems and optimization word problems. You will know an optimization word problem from across the room because they'll use words like maximize, minimize, closest, farthest, some word that describes some type of big, small thing to it. That's optimization. Plus, the fact is they don't use the word per in the units. This one, I'm talking about feet per second. They're talking about pulling things together or pushing things apart. That's related rate. So, step 1 on related rate, draw a picture and see if you can figure out what's going on here. So we have a dock. In the water here. All right. So we got some kind of interesting pulley system up here. So that's going to be my pulley. And we got clearly the dock worker with his baseball hat on. All right. So here we go. We have water. We have boat. And remember, you get extra points for drawing really cool pictures. So, as my students know, this is the only boat I know how to draw from the 3rd grade. So, crow's nest and stuff. All right, there we go. All right, so there we go. All right, and so we have a rope attached to the bow of the boat. And he's pulling this thing in. So what do we know? Give me information here. A boat being pulled into a dock by a rope is attached to the bow of the rope. The rope passes through a pulley on the dock that is 4 feet above the bow. So here's my bow right here. Here's the level of the bow. This is 4 feet. Does that make sense? Keep going. If the rope is being pulled at a rate of 3 feet per second, so you're pulling the rope this way, so this is 3 feet per second. Okay. How fast is the boat approaching the dock? The question is, we're going this way. This is where the dock is at. We want to know how fast the boat is approaching the dock. Now, when you draw these elaborate pictures, the goal is to figure out what geometric shape you're playing with here. What geometric shape are we playing with? What kind of triangle? Right triangle. Things we know about math. We have a right triangle here. On this particular right triangle, this part is constant. It doesn't change at all. The bow of the boat is here. The pulley is here. This is 4 feet. You have to label this stuff. So I'm going to call this guy X down here because it's like horizontal. I'm going to call this guy Z. So I am pulling it in this way at a rate of 3 feet per second. That is along which guy is this in terms of my right triangle? This is the hypotenuse Z, so and it's a rate. So this would be dz over dt equals 3 feet per second. Does that make sense? What are we looking for? We are trying to find pulling it in this way. That is along the x-axis, so pulling it in this way, we're supposed to find dx over dt equals what? But there's more information here. We're supposed to find dx dt, how fast the boat is approaching the dock, when it is 10 feet away. 10 feet away from the dock means x equals 10. So we're supposed to find dx dt when x equals 10. Turning the English into mathematics. Does that make sense? Did I lose you anywhere? Here comes the major part of the problem right here. From the geometric shape, you personally have to come up with the equation that links all this good stuff together. Well, you just told me it's a right triangle, and we're talking about the sides of a right triangle. So what major theorem do you know that connects all the right sides of a right triangle? Pythagorean theorem. Remember, this is constant, so I'm going to leave him as 4. But these guys change as the boat comes in, so these guys are variables. The Pythagorean theorem tells me that 4 squared plus x squared is equal to z squared. A squared plus b squared equals c squared. The sum of squares of those sides of a right triangle equals the square of the hypotenuse. Pythagorean theorem. All right? Clean it up. This is 16 plus x squared equals z squared. Okay? Now, we're interested in finding dx dt, which means I'm going to take this equation, take the derivative with respect to time. It's implicit. When you did related rate problems, it is implicit differentiation. So every time you take a derivative of a variable, don't forget that d variable dt stuff. What's the root of 16? 0. What's the root of x squared? 2x what? dx dt. You're taking derivative with respect to time. Equals, what's the derivative of z squared? 2z dz dt. All right? There's my equation. Plug in what we know, solve for what we don't know. What are we trying to find here? We're trying to find dx dt. That is my variable. So this will be 2 times something, we're going to plug in here, equals 2 times something times something. What else do we know? We know x. What's x supposed to be equal to? 10. We also know what dz dt is. What's dz dt? 3. Does that make sense? But wait a minute, I got to find one more letter. I got to find what z is. This is standard operating procedure. You've got almost all the information. But what you don't have, you can always go back and find. So I need to find z so I can solve for dx dt. So remember, your equation was 4 squared plus x squared equals z squared. X was equal to 10. So 4 squared plus 10 squared equals z squared. 4 squared is 16. 10 squared is 100 equals z squared. Z squared is equal to 116. So what's z going to be equal to? And this is a distance, so it's positive. The square root of 116. Does that make sense? Did I lose you guys anywhere? All right. We plug it in here. Square root of 116. And I get this. 2 times 10 is 20. Dx over dt is equal to 2 times 3, which is 6, times the square root of 116. Divide by 20 on both sides, and I get dx over dt is equal to 6 times the square root of 116 over 20. Okay? Now, wait a minute. What do they want me to do here? They want me to find the exact answer and then approximate it. So, this is my exact answer. But you know what? You could clean them up a little bit. What is 6 divided by 20? 6 divided by 20 is 3/10. 3 times the square root of 116 over 10. 116, does that reduce? Let's see, 116 divided by 4. Yep, of course. So this is equal to, trying to give them as reduced possible answer as possible here, 3 square root of 16, same thing as 4 times 29 divided by 10. What's the square root of 4? 2. So I can pull the 4 out and make him a 2. 3 times 2 is equal to 6 times the square root of 29 divided by 10. So I can reduce that fraction some more. That gives me dx over dt to be equal to, what's 6 divided by 10 also known as? 3 square roots of 29 divided by 5. That is that exact answer. Don't forget your units. What's your units? This is x, which is distance, time, which is distance we measure in feet, and time is measured in seconds. So what is that? Feet per second. But then they also said they wanted you to approximate this thing to 0.01 feet. So round it to 2 decimal places. So this will be 3 times the square root of 29 divided by 5, which is 3.23. 2 decimal places, 0.01 feet per second. Now, again, I'm not finished with this problem yet. We've got about 10 seconds left on this problem because, honestly, this is the wrong answer. Wrong answer. Well, it's wrong-ish. Let me explain why. And this was a debate on the committee in terms of us coming up with the answers and how many points is this. Let's go back and look at it again. Understand this. The boat is being pulled in what direction? Towards the dock. As you go towards your source, it's considered negative, and when you go away from the source, it's considered positive. Same idea. You throw a ball. If we throw it up, it goes away from the earth, that's positive, but once it stops and comes back down again, it goes negative. The velocity concept. Up is positive, down is negative. Towards the source is negative, away from the source is positive. So officially, here was the problem. Because the boat is being pulled in this direction, the dz over dt should have been officially negative 3. So when I plug it in here, this would have been negative 3, which would have made all my answers what? Negative as I go around down the line. So the actual answer is negative 3 times the square root of 29 divided by 5 feet per second, or negative 3.23 feet per second. However, we decided if they got it this far, we just gave them the credit for it. We didn't take off for the negative, but officially, if you want to be letter of the law, why would the answer be negative? Because the boat is going towards the dock. Now, you had a question, sir. What was your question? At this problem, they didn't take off anything. Can't guarantee that in the future, but you never know. Now, one last thing before you guys run away and go study some more, by the way, is this. The question proposed to me at the beginning of this lecture was, is this a good representation of what the final exam is going to look like? And the answer to that is yes and no. Yes, this is a good representation, but don't let this be the only exam you guys study. I want you guys to go back and study other exams for other styles of questions, because instead of a boat problem, maybe they do a different kind of elaborate related rate kind of problem. Don't let this be the only exam you guys study. Study different kinds of words, different kinds of wording of the questions and stuff like that. But study hard. Oh, by the way, what time you guys got to be here at the exam in the morning? And where's your exam at? Well, for my guys, Fretwell 121 at 7:30. Don't be late. See you guys then.